SN2. Or the difference between SN1 and SN2 reactions. Clear? So in this particular match, this particular difference, you may get it for 2 marks also, you may get it for 5 marks also, you may get it for 10 marks also, depending upon the paper setter or this thing. So this particular reactions will appear for either 2 marks, 5 marks, or 10 marks. 5 marks and 10 marks, whatever you know the difference, you can just differentiate, list it. That becomes difference between them. But for 2 marks, the important points what we have to cover in this difference, just I will highlight. Clear? So in the first point, it is a first order kinetics. It is a first order kinetics. It is a second order kinetics. So based on this first order kinetics and second order kinetics, you can write 1 with a degree and 2 with a degree, or you can also write as unimolecular reaction, bimolecular reaction. Anyone you can write it. That becomes the kinetics. Then coming to the mechanism, it is a 2-step mechanism. And it is a single step mechanism. Then the third point is it can undergo racemization. The product formation will be always racemic mixture. And this will undergo inversion of configuration, or Warden inversion, what it is called. Inversion of configuration. And the last point is the reactivity you have to mention. Reactivity in case of SN1, it is tertiary is going to react faster than secondary. Secondary is going to react faster than primary. Primary is going to react faster than methyl. Whereas in this case, methyl react faster than primary. Primary react faster than secondary. Secondary react faster than tertiary. Tertiary react faster than. Clear? This is what the main difference between both of them for 2 marks. For 5 marks, once again, you can just go on adding whatever you know about this SN1 and SN2 reactions. That is unimolecular reaction or a first order kinetics, second order kinetics, or you may also write it as bimolecular reaction. Then it is a 2-step mechanism, it is a single step mechanism. And here it is racemization takes place according to stereochemistry. Here it is inversion of configuration takes place. This inversion of configuration is also called as Walden inversion. Walden inversion. Walden is the name of a scientist who discovered this particular reaction. That's why it is named as Walden inversion, but it is actually inversion of configuration takes place, Walden inversion. And the last point is reactivity. Tertiary reacts faster than secondary. Secondary reacts faster than primary. Primary reacts faster than methyl halide. Whereas in case of SN2, methyl halide reacts faster than primary. Primary reacts faster than secondary. Secondary reacts faster than tertiary. This is what the difference between these two. And one more point here I wanted to mention is some factors which are affecting this particular SN1 and SN2 reactions. But those factors we'll discuss in some other chapter. but I'll just mention the factors affecting this nucleophilic substitution reaction SN1 and SN2. SN1 and SN2 both factors affecting SN1 and SN2 reactions. One is nature of substrate. That is alkyl halide. Then the second one is a nucleophile. Nucleophile, that is Nu with 2 dots, or maybe Z with 2 dots, or B with 2 dots. Then the third one is leaving group. That is X. Then the fourth one is effect of solvent or nature of solvent. So these are the 4 factors which are affecting this particular SN1 and SN2. We'll discuss these particular 4 factors in some other time, but just simply mentioning these 4 factors because I wanted to complete that particular line in the syllabus. That is nature of substrate. As I told you, if it is methyl halide, it will react with SN2 reaction. If it is primary alkyl halide, it reacts with SN2 reaction. If it is tertiary and secondary, then it will react with SN1 reaction. That is what the nature of alkyl halide. Okay, nature of alkyl halide. Then the nucleophile, the concentration of that nucleophile is also very important to carry out the reaction. Then the leaving group, either if it is Cl, then what type of reaction? I mean, what is the time required to complete? If it is bromine, what is the time required to complete? If it is fluorine, iodine. So based on the presence of this X, fluorine, fluorine, bromine, the reaction rate will be affected. And the nature of solvent. Once again, we'll discuss this particular topic in some other time, but this solvent also plays an important role to complete the reaction in less time or to complete the reaction within stipulated period. So this nature of solvent is also very important. These are the 4 factors which will affect for SN1 and SN2 reactions. This is, I think time is up. I'll complete this today.